Hello everyone, welcome back to another Java video. Today we're going to be working with loops and we're going to solve this factorial calculation problem. If you don't know what a factorial is, it is the exclamation mark operator in math. And basically what it does, it takes a number, and if you apply the factorial operator on it, you're going to multiply all the number that came before it all the way up to 1 and the number that you are using the factorial operation of. So in this example, I have factorial of 4, and I get to do 4 times 3 times 2 times 1, and that gives us a value of 24. And most likely there is a factorial method that already exists in Java, but we're going to mimic this operation by using our loops in Java. So let's get started. Our first solution is going to use the while loop, and our second solution is going to use the for loop, and we'll do both of those solutions in this video. Right now, I just have my boilerplate ready for my Java program, and then we're going to get started. So first thing I'm going to do is say variable initialization. And I'm going to create a variable, an integer variable called product. And I'm going to set that to 1. The reason why I'm initializing it to 1 is because we're going to be doing a lot of multiplications. And if I multiply a value by 0, you're going to get 0 over and over and over again. Therefore, the smallest multiplication value that we want to have when we're initializing a variable, we can just set it to 1 for our program. Okay, let's handle our input. So we can just write a little message, a prompt. Enter a value of n. And then we can go string input is equal to let's see on next line. And then we're going to convert that to an integer. So integer num. Actually, let's have a better word. Let's call this upper limit. And we're going to say that this is an integer dot parse int. And we're going to be converting that to input. Okay, we have now converted our input to an integer. We have our upper limit. Let's get into our solution part. While loop. So to use a while loop, we must use a keyword called while. So we're going to go while. We're going to have a little condition here. And we have to write our curly braces to say that everything we write inside is going to belong to the while loop's code block. Okay. So what we want to do is really just take our number that we've been given, our upper limit, and generate all these numbers. Okay. So for simplicity of my life, I'm also going to create a variable called the counter. Okay. So I'm going to create int a counter is set to 1 semicolon. And what I want to do is just really increase this counter every time my while loop executes so that I can generate 1, 2, 3, 4. And as long as I start generating these numbers, I want to start multiplying them all together with this variable that I created called product. Okay. So we're going to say, well, while our counter is less or equal to upper limit, and as long as this condition stays true, we get to execute our code block. Our code block within while executes as long as this statement is true. So here we go. What we want to do is first update our product. We want our product to be equal to whatever it was prior multiplied by the current value of our counter. So we just did 1 by 1, 1 multiplied by 1. So since I've finished, now I need to start prepping for the next loop. So I can say counter plus plus. We are increasing counters so that we can multiply product with a new number. And I'll just leave a note like that. And this is going to go on. And we want to do this for two folds. We want to calculate our factorial number. But also, we want our while loop's condition to at one point become greater than upper limit, which makes our condition become false so that we get to exit our loop. Otherwise, we'll be stuck in an infinite loop. Okay. And after, when this while loop is finished, we should be able to get an output that we need. So we're going to go system.out.println. The factorial is, we can write a little plus symbol here, and we can output the value of product. Okay, so let's run our code. All right, so I need to enter value of n. So we know that our value of 4, factorial of 4 is 24. So let's see what it gives us. And we get factorial value of 24. So how does this work? Well, in our while loop, our counter is 1 and our upper limit was set to 4. So this condition ended up being true. We take the product value of 1 and we multiply by our counter value, which is currently 1, and we multiply that, product is back at 1, but our counter now increases. Now 2 is still less than equal to our given value of 4, so now we do 1 times 2, product has now grown to 2, counter becomes 3 at this line. We go back up and we check our condition over and over again so that our while loop can execute or not execute, because as long as that condition is true, we get to execute our code. So we have 3 is still less than or equal to 4. So we do 2 times 3, that gives us 6, and counter goes up to 4. Counter of 4 is still less or equal to our upper limit. Therefore, we do 6 times 4. That gives us our 24. Counter is now 5. We go back and check. 5 is not less than or equal to upper limit of 4. We get to now exit our loop so that we can execute this line of code right here. And then we end our program. Right. So that was using a while loop. What I'm going to do now is, well, I'm going to mimic this kind of feature, but turn that into a for loop. So I'm going to comment that out by clicking Control slash, and we're going to do a solution using a for loop. Okay. So at this point, we want to use the keyword for. And just like we had to initialize this variable called counter and increase it every time we use our loop, all right, we're going to be essentially doing the same thing, but a nice thing about a for loop is that, well, we can do that within the for loop's condition clause. We can create a variable inside and set that to 1, and we use a semicolon here. We're going to say, give it a condition of when should the for loop stop, or when should it loop, as long as the condition is true. So we're going to say counter is less than or equal to our variable that we set as upper limit. And how should we modify this value called counter? Well, we want it to go up by 1 every time, so we're just going to use this operation of counter plus plus, which is the incremental operator. And then what we can do is just write this line of code right here. So a for loop was more efficient in terms of writing and cleanliness to do a problem like this, because most often for loops are designed to solve numeric problems. So we don't need to do something like this. While loops are condition-based loopers, so that most likely while loops are designed to solve almost every iteration type problems. Okay, but a for loop is really designed for helping us solve numeric based problems where we have a finite start and a finite end. So let's now save this code and run our program. So if I execute this code with 4 now, we're going to get 24 is working as intended. If I were to give it a 5, we're going to get 120, because 24 multiplied by 5 gives us 120. So this was how you can write a for loop to do the exact same solution. And this was how you can write a while loop to do the same solution as well. Okay. And as always, thank you for watching and stay classy.